Okay, so this is another electrostatics video, this one dealing with conservation of energy. Whenever we've talked about conservation of energy this year, we have it set up like this, where kinetic initial plus potential initial plus work that you do is equal to kinetic final plus potential final plus any energy that's lost to heat or friction. To make these questions a little easier, we're not going to worry about friction for this stuff, so we're just going to be considering this equation we're left with. Remember that for all of these equations, for this stuff, kinetic energy is still 1/2 mv squared, and potential energy for electrostatics is k q1 q2 over r. And it's going to be important here to keep negative signs on your charges. So for this, when we consider electrostatics, we have to remember that like charges will repel and opposite will attract. Right, and that's going to be how we sort of set up our energy questions. So let's say that we have a positive 6 microcoulomb charge, and we have an electron that's some distance away. And let's set our starting distance, I don't know, let's go with 10 meters. So if the electron were released and allowed to move that way, it would convert initial potential energy into final kinetic energy, and there would still be potential energy at the end. So let's consider a point where it is now 8 meters, and we want to know the speed of the particle when it reaches that, or the electron when it reaches that point. So we're not going to have any kinetic energy for this starting, we'll only have potential to start. So EPI converts to kinetic final plus potential final. So to set this up then, potential initial is K times 6 microcoulombs times negative elementary charge, we keep the negative sign in for our electron, all over 10 meters, equals 1/2 times the mass of an electron plus our final potential times elementary charge, all over a final value of 8 meters. So now we can solve our speed by punching all this in. It's going to be a bit of an ugly calculation for a minute. 9 times the 9 times 6 times negative elementary charge, all over 10 meters, minus, again, negative elementary charge over 8 meters. Divide that by the mass of an electron times 1/2. Square root our answer, and we're left with 2.17 times 10 to the 1, 2, 3, 4, 5, 6, 7 meters per second.